All right, looks like we're up and running. It says it's recording. Let me get a full screen for myself here. So this video is going to be, if I had just 2 minutes to talk about a linear function, a quadratic function, or a cubic function, what would be the thing that I would highlight? That's all I have, it's 2 minutes. All right, yeah, I'm retiring and I got another week of classes and I just was thinking, I've been working with this stuff a long time. So I thought I'd share what thoughts came to mind. Before I do that, I want to give credit to Rennie Descartes for all the videos. I don't think it'd be possible. So let me show you Rennie. Where are we, Rennie? There's Rennie Descartes right there. It's got some stuff underneath. Yeah, and so Renee's allowed me to walk around the room like this and appreciate it. So we'll get that acknowledgement. And now moving forward. So here's your typical point slope form of a linear function. And I just threw some things on the board 2 minutes ago, so no rehearsal here. And I got about a half an hour before I got to be someplace, so it's got to be quick. So point slope form. And if there was one thing, I would want to highlight this aspect of that linear function. I think that's the most important thing, is seeing how this works. All right, we have division, multiplication and division. Neither one's more important than the other. They're really the same operation. Dividing by 3 is multiplying by 1/3. So if you're going to divide by 3, and order doesn't matter here, what would be nice to be in the parentheses? Well, I would hope you say the multiples of 3. 0, 3, 6. Going in the positive direction. Could have gone in the negative, but it's easier to go in the positive direction. And if you see that, then it's real easy to just start putting what makes a 0, what makes a 0 here, what makes a 0 here. You've got a coordinate, right? But seeing this allows you to immediately do this. And then you have user-friendly numbers, and you can begin to plot more easily. That's it. I don't think that was even 2 minutes, but I think that's the most important. So let's do it. Let's take 30 seconds and you pause the video and I'll throw some coordinates down and just plot them, and we're off and running. We started a conversation. So you pause the video. I'll come over here. I like to move. This used to be y minus 9. I like to put it there because I like to play. I like to play with that form because there's a lot to do with it, with a cubic and so on and so forth, all the way up 4th and 5th and 6th degree polynomials. All right, you've paused the video. I hope you see minus 2, 9. And then on this side, I'm going to change by 7. 5, 12, 19. Okay, and if you want to put in the other side, then you're going down by 5. So you got your 4, -1, and your -6. That's very helpful. So you plot those points, you got the line. All right, let's go look at the quadratic. What's most important? Well, if I wanted you to remember something coming out of your Algebra 1 class, it would be x equals minus b over 2a. Well, first off, I think it's very important that you understand that all of this comes from geometric shapes. All right. Changing rectangles into squares and whatnot. And I think the geometry unlocks understanding here. So feel free to go to the quadratic playlist and look at completing the square. And then when we get to the cubic, go look at completing the cube geometrically. I think that holds the key to understanding. And Newton basically played with, I think it was in Principia, I saw an old textbook, and playing with the shapes. So I think it's important. If he's doing it, it's important. If he did it, excuse me. All right, quadratics, 2 minutes. Minus b over 2a, f of minus b over 2a. That basically, along with knowing the a term, which is given, ax squared plus bx plus c, and knowing the a term, then you can sketch quickly. You can find the roots quickly. You can solve any equation quickly. You can put it in graphing form, and you can find the maximums and minimums, which means you have the range. All at your fingertips, just by knowing that. That's most important. Understanding where it came from, go to the playlist. So we'll do one. All right, so let's do minus b. These are canned problems. I tried to make nice, user-friendly integer problems. So you pause the video, you find x equals minus b over 2a. There are lots of patterns here. You do f of minus b over 2a. Yeah, you sketch it, so on and so forth. Everything that's over here, I'm gonna do. All right, we'll see you over there. Yep. All right, so minus b over 2a. 20 divided by 4 is 5, so we know x equals 5. Put 5 in, and you'll see a nice pattern here. You got 50 minus 100 plus 7. If I don't make a mistake, I believe I'm looking at minus 50 plus 7, minus 43. So we know we have cup shape up, and we now know that we have 5 minus 43. 0 gets us 7, 0's on this side, 0 gets us 7. You can always find the other coordinate, no problem. But you got the roots. All right, so 0's here, so therefore, measuring from the frame of reference, we want an x value of 5, plus or minus the square root of 43 units divided by 2. All right, there's your roots. You want to find when it equals 7, then you would go from negative 43 to 7, you would go 5 plus or minus the square root of 50 over 2. That's how far it is. And then you would have found that height. So go ahead and check it out. So what's our range? Our range is y values greater than or equal to negative 43. What's our graphing form? Our graphing form over here, 2 times x minus 5 squared minus 43. I think I came in under 2 minutes with that. No problem. All right, that's what the video is about. What's most important? All right, so changing any cube, which is a box, into a perfect cube, which is, oh, I didn't even draw it yet. Perfect cube gets us started with the graphing form for a cubic. So go to the playlist, look at completing the cube geometrically, and it's done for you. All right, so what's most important here? Did I write it down? Yes, I did over here. Minus b over 3a, minus f of minus b over 3a, and one little thing you got to memorize, c minus 3ah squared. If you can do that, and I don't think it's a big step up from what we just did with the quadratic, and you remember c minus 3ah squared equals m, and this is the graphing form for a cubic, m is the rate of change at the point of inflection, you got some ownership of this. So let's do it. I think I did a video of 5 practice problems a few days back, getting started again. So minus b over 3a, let's see, x equals minus b over 3a, put the clock on there, gave you a nice easy one, 6 divided by 6, 6 divided by 6 is 1. Okay, so therefore I know if I put a 1 in, nice easy problem, 7 minus 16 minus 9, I believe, 1 minus 9, then I know right there, I have a point of inflection. You also know 0, 5 just by looking at it, right? So just a little to the right of the y-intercept, so it's probably something that looks like this. Okay, what's the slope there? The slope there is, did you remember, c minus 3ah squared, where h is minus b over 3a. So therefore we have minus 10 minus 3 times a, 2 times h. The coordinate was 1, negative 9. So h is 1 squared, and that gives me minus, 16? So I'm going down at 16 to 1, and therefore I have my frame of reference for my local max, which is x, I already wrote x, which is 1, my frame of reference. I'm to the left of it. And it turns out it's the square root of the opposite of this, divided by 3 times a. And this one is x equals 1 plus the square root of 16 over 3. All right, I think I'm done. It's also nice to put the y-intercept in there, and the slope there is minus 10. I'm going down quicker here. So somewhere in there is 0, 5, right? And that's what I think is most important. So what's the graphing form? The graphing form is 2x minus 1 cubed minus 16, x minus 1 minus 9. That's the same thing as this, but you can see what's going on. Now, what would happen if this was, so that's a minus what? Minus 6. So what if this was positive 10? Well, if that's positive 10, then I'm going up. And I don't have any maxes and mins, so I'm always going up. Okay, so those are the things that I think are most important for the linear, the quadratic, and the cubic. All right, and if you want to know more about that, go to the cubic playlist, look at completing the cube, putting it in graphing form. God, it must be 20 videos there. Okay, have a good day.